Welcome to this lesson on function tables. Please make sure you have these notes in front of you so we can begin our lesson. And my students, let's make sure we update our table of contents. The learning objective for this lesson says I can explain the relationship between dependent and independent variables. The first vocabulary word we're going to talk about is called function. And a function is a relation that assigns one output value to one input value. And we will further discuss what an output and an input value means. But first, let's talk about what a function rule is. A function rule describes the relationship between each input and output value. Independent variables, or the input value, is a variable whose value does not depend on another. The dependent variables, or the output value, is a variable whose value does depend on the input. So think of it this way. I know I just threw a bunch of different vocabulary words at you. For independent variables, or for the input, think of people who are independent. They don't need anybody else to support them. However, for dependent variables, think about people who need other people to support them. Alright, so let's talk about these key concepts so that we can further explain the concept of independent variables and dependent variables. So think of your favorite sport. The hours practiced is going to be known as the independent variable. The games won is called the dependent variable because the amount of games that you win will depend on how many hours you practiced. The second example, temperature. Temperature is the independent variable, or the IV, or the input. Ice cream sales is the dependent variable because the ice cream sales will depend on the temperature. The next example is time studied. The time studied is your independent variable. Your test grade is the dependent variable because your test grade is going to depend on the amount of time that you studied. So if I input a lot of hours practice, I will win more games. If the temperature goes up, if I input the temperature going up, then the output would be ice cream sales will go up. If I input more hours of studying time, then the output would, my test grade will go up. So think of a function as a function machine. We are going to take a number that is the independent variable, or the input, and we're going to put it into this machine, and the output will be a number that is the dependent variable. This number will depend on whatever this number is. So let's use these key concepts to discuss the following examples. For example 1, it says the output is 7 more than the input. Complete a function table for this relation. Function rule is x plus 7. So this is the relationship between the input and the output. We're going to add 7 to each input. So I'm going to call the input, this is going to be my IV, my independent variable, and my output would be my DV, or my dependent variable. So if I take any number like 10, and I plug it into the function machine, the relationship is 10 plus 7, the output becomes 17. So if I place 10 into the machine, something happens, and then the output number becomes 17. Let's take the input number like 12 and put it into the machine and add 7 to it. The output number becomes 19. Notice the output number 19 is depending on the number 12. Then I'm going to take the number 14, that's the input, place it into the machine, add 7 to that. The output number becomes 21. Notice the output number 21 depended on the 14. For example 2, it says the output is 5 times the input. Complete a function table for this relation. Then they say that the function rule is 5x. So this 5x means 5 times x. And that is the relationship between the input and the output. So we're going to multiply each input by 5. So I'm going to identify the input as the independent variable and the output as the dependent variable. So I'm going to take the input variable, like 8, and I'm going to plug it into the machine. So 5 times 8. Once I do the math, the output value becomes 40. Notice the value 40 depended on the input value. Let's take the next number, like 10. 5 times 10, plug it into the machine, so 5 times 10 becomes 50. The output value is 50. This number 50, the output, depended on the input value of 10. Let's go ahead and take the number 12, place it into the machine, so 5 parentheses 12, which means 5 times 12. When we do the math, we get 60. The output value is 60. So this number 60 depended on this number 12. So go ahead and pause the video and complete these Got It problems, and we'll discuss the answer in class tomorrow. Notice I have two Got It problems on this slide. I've got Got It problem A and Got It problem B, and please be sure that you show us the table for both input and output values. For example 3, it says find the input for the function table. So this problem, we're going backwards. Instead of them giving us the input, they're now giving us the output. So they give us the relationship. The relationship is in this box right here. The relationship between the input and the output is 3 times x. So I can write it like this. 3 times x should equal my output. So I can solve a problem like this. I can draw my fulcrum down the equal sign, divide both sides by 3 to keep the equation balanced, and x is equal to 2. So my input is equal to 2. Let's go back and check this work. If I say 3 times 2, if I plug it back into the relationship, I get the output of 6. This output depended on this input. So let's try another one. 3x, which is our relationship, should equal to our output. The output now is equal to 15. Let's go ahead and draw our fulcrum down the equal sign, divide both sides by 3. So the value of x is equal to 5. So our input is equal to 5. Let's go back and check to make sure this is correct. Our relationship is 3 times x, so 3 times 5, and 3 times 5 equals 15. So our output depended on our input. So let's go ahead and do the last one. 3x, which is the relationship, should equal the output, which was 21. Let's draw our fulcrum down the center, divide both sides by 3, and the value of x is equal to 7. So the input is equal to 7, and let's check our work. 3 parentheses 7, that's the relationship, so 3 times 7, we get 21 as our output. So our output depended on our input. So pause the video and complete this Got It problem, and we'll discuss the answer in class tomorrow. For example 4, it says the Gomez family is traveling at a rate of 70 miles per hour. The function rule that represents this situation is 70 times x, where x is the number of hours. Make a table to find how many hours they have driven at 140 miles, 280 miles, and 350 miles. Then graph the function. So on this graph, they're giving us a column for input. They're giving us the column for the relationship, which they gave us in the problem. So 70x is the relationship between the input and the output. And what we have to do is we have to work backwards because they're giving us the output. So I can write this. 70x is equal to 140. We can draw the fulcrum down the equal sign and divide both sides by 70 to keep our equation balanced, and the value of x is equal to 2, because 140 divided by 70 is equal to 2. So my input is 2, and if I check my work, 70 times 2 does get me 140. So let's try this again. Let's say 70x is equal to 280, because that's the second part that I have here. Let's draw the fulcrum down the center of the equal sign and divide both sides by 70 to keep our equation balanced. So the value of x is equal to 4. So my input is 4, and let's check our work. 70 times 4, if I do the math, I get 280. Let's try one more. Let's take our function rule, which is 70x, and set it equal to 350 now. Draw the fulcrum down the center of the equal sign and divide both sides by 70 to keep the equations balanced. So the value of x is equal to 5 when I divide 350 divided by 70. So 5 is the input value. So we can check our work by saying 70 parentheses 5. And we multiply 70 times 5, we do get 350. So if you look at it, the input becomes the x values and the output becomes our y values. So we can create a set of ordered pairs. So for our first ordered pair, we got 2, 140. Our second ordered pair, we have 4, 280. And our last ordered pair would be 5, 350. So let's go ahead and plot these on the graph. We're going to start with 2, 140. So I'm going to go on my x-axis, go over to 2. And I'm going to go up to 140, which is about this location right there. It doesn't touch the 150 mark. And then let's go ahead and go to 4, 280. So 280 would be right before the 300 mark. And then the last one would be 5, 350. So I'm going to go over on the x-axis. And I'm going to go up on the y-axis up to 350, which is about here. So you can see the relationship. The more the family drives, or the more hours the family drives, the longer the distance the family goes. So pause the video and complete this guided problem, and we'll discuss the answer in class tomorrow. Please be sure to show a table and a graph for this problem. So now that you've completed this lesson, go ahead and self-rate yourself and let us know how you feel. If there's any part of this video that you do not understand, please go back and watch it again. Also come to class with some questions so we can discuss it in further detail.